Continue discussing things where uncertainty works the same way as risk. Now I'm going to put up in one blow a big figure that's very similar to something that you saw before. The only thing is before we had probabilities, now we have events. For instance, if we look in the middle figure, the reference case and the left prospect, before you saw this where there was probability P1 there, now we have event E1, we had a probability P2, now event E2, we had a probability Q, now the event A, capital A. And you see here is again this common outcome, capital C. We do much like we did with risk. Still, in each figure, the best outcomes are depicted in a higher place. So higher places have better rank. And still, green indicates the direction where you want to go. So all the same as with risk. And again, we assume that we chose the outcomes in the reference case such that we have indifference here. Then we're going to see what happens if we change the common outcome. For instance, capital C here is ranked in the middle between the other outcomes. In the left fig, we replace it by a capital C plus common outcome that was superior to all the other outcomes. What happens with preference? Well, we have, you know that the sure thing principle says that changing a common outcome into another common outcome should not change preference. Sure thing principle predicts left case same as the reference case, so indifference. But empirically we find that the preference changes, so we have falsifications of the sure thing principle, and I already explained with risk that they provided useful critical tests of optimism and pessimism that continues to hold just the same way for uncertainty. I'm going to explain one case to you, leaving the others to you. You can think through yourself, and it's just the same as risk, so you can do it. So I consider one case where in the reference case here, we compare it with the left case, and we see what happens with a pessimist. Okay, well, again, the lower branch is the same in both panels. It has the same rank, everything the same. So that doesn't make us think the preference will change. Let us look at what is this capital A event. Here it is the middle event. It's ranked middle. It has the common outcome. It is a neutral argument. It's neither argument for going left nor for going right. It's a neutral argument. In the left case, the rank of that event has changed, but it continues to be a neutral argument. No reason for going left or right. So it works the same way for preference, and it can neither suggest to us that preference would change. Finally, we look at event capital E2, the highest event here, and we see in the left case, it has changed rank. In the reference case, the middle figure, it has the best rank. Here in the left case, it has middle rank, so a bit worse. Well, we are assuming pessimism, and a pessimist, the worse events are, relatively speaking, the more attention is given to them, more decision weight. So therefore, this event capital E2 it receives more decision weight in the left case than in the reference case. Well, event E2 is an argument for going left, because there's green, there's the bigger outcome. So that means in the left situation, the only thing changed is that an argument for going left has been reinforced. Therefore, we say a pessimist in the left situation will prefer the left prospect. Okay, for optimism, we can do the same reasoning for inverse S or likelihood insensitivity. Everything goes the same way as risk, same critical test, and I will not discuss it any further. But I'll go on to the next topic, and that maybe I can remind you of the operational spirit that we have in this course. For these theoretical constructs, we want to know, link them to empirical reality. So we want to know how can we measure them. Again, you heard it often, we do it again. Now, in our rank-dependent utility for uncertainty, there's a capital U, the utility function. Now there's a capital W, weighting events. How can we measure them in experiments? And it turned out that the experiment that we already did is that's the way to do it, still works. So that experiment, the more and more we proceed in this course, the more and more general theories we get, but the experiment always continues to be valid on the very general theories. So it has big validity and much robustness even against ambiguity, attitude, all these things, as we are going to see now. So I'm going to remind you of the experiment. Here you see these were the measurement of the alpha, the first figure that you filled out. You had to find alpha 1 up to alpha 4, keeping you indifferent in all these panels. And there was candidate 1 and 2, one of the two was winning. You remember the situation. We're going to analyze it now using rank-dependent utility for uncertainty. I repeat the first two panels, figure 1A and B, the measurement of alpha 1 and alpha 2. I did not write candidate 1 and 2, but you remember the branches at candidate 1 and candidate 2. I'm going to assume, and you take my word for it, we can still do it. Again, I'm going to assume utility 0 at alpha 0, utility 1 over 4 at alpha 1, and then I'm putting up in one blow here all kind of complicated calculations. You've seen it before. These were calculations for decision under risk where we had probabilities half given, which is not our case right now. But I still put them up here for comparison. And now, of course, we don't have probabilities half, so I have to cross them out. Now we have to change a few things. We have to, everywhere where we had the probability half and we took the small w value of it, it was concerning the upper branches. Now, in the upper branch, we have candidate 1, and the decision weight of the upper branch is now capital W of candidate 1. Your upper branch has the best outcome, it's alpha 1 here. And that's the only change. If everywhere we carry out this replacement, the whole reasoning goes through. Although the W's are now different, they cancel anyhow. And we still end up saying utility alpha 2 is 2 over 4. I look a little bit closer. For instance, here the left prospect, the rank-dependent utility, well, we start with the best outcome, alpha 1. The outcome event corresponding with it is candidate 1. So the decision weight is capital W of candidate 1. And that's indeed the replacement here. So this formula indeed gives the rank-dependent utility of the left prospect. This formula with the replacements gives the rank-dependent utility of the right prospect. Okay, everything works as it is written here, and it is quite similar to risk. So we can continue this way. I will not show it, but we can also show that that the utility of alpha 3 is 3 over 4, and that the utility of alpha 4 is 4 over 4. The alphas are still equally spaced in utility units, just like it was before. Also, went quite a while back, you drew your utility graph for using your alpha values. That continues to be a valid utility function, also if you were not ambiguity neutral, if all kind of uncertainty attitudes were going on. So it holds in great generality. There were also figures with beta. I will not show them, but you may remember that then the lower branches gave the best outcome. There were a small g and a capital G there. So if then you do rank-dependent utility, you start with the best outcome, which is the lower branch. So you get the capital W applied to candidate 2, which is providing the decision weight of the lower branch. And the branches with the alphas, the upper branch, now have a decision weight 1 minus capital W of candidate 2. So now here you have these calculations, but instead of this W half, you have 1 minus capital W of candidate 2, if you can follow. But anyway, whatever you write there, W half small or capital W of candidate 1, or 1 minus capital W of candidate 2, whatever you write there, it's cancelling anyhow. So it continues to be valid to similar reasoning, and indeed, it continues to be true. Also, the betas were equally spaced in utility units, and in particular, the betas have to be equal to the alphas. So that prediction that we made holds in great generality. It also holds if ambiguity attitudes play a role, if we have rank-dependent utility for uncertainty. We also had in the experiment a measurement of the gammas, but they were using probabilities half, so we can't easily do something similar. So no more about that. There was a measurement of deltas, and by just common sense, they had to be equal to the alphas, and that continues to hold here. So also now on the rank-dependent utility for uncertainty, even much more general theory, just transitivity and stochastic dominance or monotonicity. The deltas should be equal to the alphas. And finally, there were questions in which you had to substitute probabilities, making you equivalent indifferent. And of course, we cannot exactly do that right now. We have to do a bit different. But you will remember that for decision under risk, there was a very nice result coming from it, that these probabilities that you substitute, they gave us in fact a measurement of the probability weighting function. And it turns out that for uncertainty, very similar things can be done. And then we're measuring the weighting function of events, capital W. So that's following. I put up the figure that does most of it. So here I have an indifference with alpha j being indifferent to a gamble giving you alpha 4 or alpha 0. We saw that with risk also. Only now we put here an event. Before we put here probability PEJ, superscript j. Now we put here an event. And here the complement of the event, of course. And then it readily follows, and I just write it, that capital W, the weight of that event EJ, must be j over 4. It just readily follows from substitution, and you can easily see it. So here you see we must set up such indifference, and we must choose this event E with superscript j, exactly so big or small enough that it brings you indifference. And then we know what the capital W value of it is. So indeed, we can also measure the weighting function of events completely similar as we did it with risk. So indeed, many things for risk continue to hold true for uncertainty, but also uncertainty is a much broader domain. It's like if you compare monetary outcomes with non-monetary outcomes, it's a bit like that. If you compare probabilizable events with non-probabilizable events, there's so many uncertain events, so many kinds of course, it's a much bigger domain. There will be many phenomena showing up in that domain that do not show up in decision making under risk. That will be the topic of next recordings.